Hi, I'm Victor Vega, and I want to introduce a new technology to you where we're using RFID to actually configure electronics. In this particular case, we have interactive Gen 2, where we're bridging the gap between electronics and a wireless interface. What we're doing is we're using a reader and an antenna to passively talk to a device, which in this case is going to be a tablet, similar to the one you see here. The difference here is instead of just passive RFID, we have an I2C serial interface where we're connecting directly to the microprocessor of this device. And what we derive from that are three basic buckets of utilization for this new technology. One would be conventional track and trace, where we can wirelessly retrieve the serial number from this device. The other would be provisioning and wireless lightweight authentication. In this particular case, we could deactivate the unit if it's not intended to go through a sales channel. At the point of sale, we could reactivate this. And then the final is configuration management. And in this particular case, we'll show you some very interesting approaches to customization of a device inside of a sealed box. So with that, I'd like to turn to a demonstration. Talking about how you could use this and why you might want to benefit from RFID inside of a tablet, we'll take an example here. More and more smartphones and tablets have metal backings, and they also have non-removable batteries. So for example, my smartphone here, there is no removable cover, so I cannot retrieve a barcode or an identifier of this particular product. If you look at the back of this, there is no serial number, and there was no serial number on my phone. You don't want a barcode on this because it takes away from the aesthetics. And you can't put an RFID tag on this because it would be shunted by the RFID, by the metal of the bezel. So we have a predicament here where we need to track it, but we have no means other than electronic serialization. So what we've done is, on the circuitry that would be placed inside of the tablet or the smartphone or any other electronic device, we integrate an antenna. And by virtue of just placing the SOT package of the RFID chip, this becomes a tag. And instead of this being an inhibitor, this becomes an enabler, and we get even further read performance. So what we do here is we activate our tablet, and in this particular case, a tablet is inside of the box. I've already pre-programmed this in the manufacturing line. As I bring this to my reader, which is behind the television, you can see that I have my serial number. I have now logged my serial number, my lot number, my model number, my firmware revision, my location of the manufacturing site, and so on and so forth. In this particular case, let's give it a new model number. Maybe it's NXP1234, and a new serial number. In this particular case, I have 5555, and perhaps I've changed my firmware revision, which I can also upload to 4.2.9. I might also want to change my manufacturing site from San Jose, California to China. I write to the device, and as soon as I'm finished writing to that device, I clear the screen, take it away from the reader, I represent it, and at that point, what we just wrote has now been put inside of the tablet, inside of the sealed box. So this is how you would use this in the forward logistics. There's a few use cases that you can imagine where this could be useful. For example, one of the use cases would be this. Fraudulent activity occurs where you purchase a tablet, and inside the tablet there's a motherboard and a daughter board. What goes on sometimes are they remove the motherboard, the daughter board, and they sell that to a repair shop. They fill this up with lead or dead weight, they seal it up, they go back to the unit, to the vendor, and they return the unit, getting a new one. Now they practically bought this for free. The problem with that is that the vendor and the manufacturer lose out on their money. By virtue of placing this in front of the reader, you can actually read the components without taking this apart. The other application is this. You buy a tablet on the internet, perhaps you bought this for $50. Then you go to a major retailer, you buy an authentic one because this one died. You have no way of knowing if this was the authentic one or not. So what fraudulent activity occurs is they remove the serial number, which might be the barcode, from the good unit. They put it on the bad. They return the bad unit. and they get a refund. So effectively they got that for free. The retailer loses out, so does the manufacturer. In this particular case, since it's inside of the circuitry, it's tamper-proof. You can't remove the tag. Now let's go beyond this. And we'll show an opportunity where you can actually take the tablet and the retailer can actually benefit from it. In this particular case, I will customize this and I will register it, for example, to myself. Having one SKU versus 3, 4, or 5, where I could designate the language or the regional provision, might be very beneficial to the retailer. In this case, I'll choose English. But here's another opportunity. If this tablet was going to be given as a gift, say for example to my mother as a Mother's Day gift, instead of purchasing a $6 or $8 Hallmark card, I can provide an upsell opportunity and put the graphics permanently on the tablet. I can also put a customized note, and that could be an upsell opportunity for the retailer as well. So in this case, I could choose a Christmas card, birthday card, or Mother's Day card. I'll go with Mother's Day card, and I type in a message. In this particular case, I've been charged an upsell opportunity for a backdrop of the appropriate occasion and also a message. Now I can take it one step further, and for the an upcharge, I can also push an e-gift certificate, and by virtue of selecting the gift certificate of interest and the value of interest, I can have a customized gift card placed onto the tablet itself. Now I personalize this. The unit then gets shipped to the recipient, in this case my mother. She opens the completely sealed box, turns the unit on, and just like we selected different things here, I could also configure her Wi-Fi such that if she's technically challenged, I could have had that set up for her as well. When she turns the unit on, you can see the same graphics that we selected on this and the customized message. Additionally, if the unit were to fail, and it's a catastrophic failure, I bring that back to the service center, and not only can I get the serialization information and the registered owner, but in this case, I extract the error code from the micro, and I can see here that I have a battery failure. So it's bidirectional communication where you can actually talk to the micro and the micro can talk back. Additionally, what we've done is facilitated the implementation of this chip by virtue of taking the U-code I2C, working with a partner, Murata. Murata places our U-code I2C in a separate package that has a matching network. What the matching network does is it helps those that may not be familiar with designing antennas automatically and dynamically adjust to impedance changes that might occur within your tablet, your smartphone, or other electronic device. So within the next 2 quarters, you will find an opportunity to purchase a matching circuit from Murata.